Again, good day everyone. So for today we are to discuss lesson 4, Reduction to Kinematics, Motion Graphs, Motion in One Dimension. And this would be a part 1 out of 3 lecture videos. So this part would introduce to you certain concepts and foundations that you need to know before we try to solve problems involving kinematics and motion graphs. So let's review our learning objective. So we should be able to convert a verbal description of physical situation involving uniform accelerated motion in one dimension into mathematical description, which means that from word problems, we have to convert it into mathematical description. Next, we have to interpret velocity time graph, displacement time graph, and acceleration time graph. And we should also learn how to interpret the slopes of the following graphs I have said a while ago. We also have to learn how to solve for unknown quantities in equations involving one dimension or uniformly accelerated motion. Again, for your diagnostic question, by the end of this week, you should be able to answer using the correct terminologies to the following question, which is, how is the motion of an object described through graphs? For this week, we have 6 topics. We are to start first by reviewing the definition of mechanics and kinematics. We also have to understand what do we mean when we say an object in a motion in one dimension. We are to also graph position versus time graphs, velocity versus time graph, acceleration versus time graph, and how do we convert from one graph to another. And of course, we cannot do that without learning first how to interpret motion graphs. So these are our topics for this week. We are to start first by reviewing our previous topic, which is a scalar and a vector quantity, but this time, how do we apply them in terms of motion in one dimension? So we have few terminologies such as distance, speed, and acceleration. In terms of vector, we have displacement, velocity, and acceleration. So what do we mean by these? Meaning, there are certain physical quantities that when we add a direction to it, it became a vector quantity. For example, in terms of distance, distance, if we describe it as, for example, an object moving in 5 meters, so without even giving the direction, it means that we are pertaining or discussing something in terms of distance. However, when you say that object is moving 5 meters north, since we give it now a direction, it became a displacement or a vector quantity. We also have speed. Speed is meters per second. So when we say an object is moving at 5 meters per second without giving its specific direction to where is it moving, it means that we're just pertaining to speed as a scalar quantity. Meanwhile, when we say the bus is moving 5 meters per second north, we are now describing it with a direction, which means we are now pertaining to velocity. In terms of acceleration, it's quite tricky. So the only thing that you have to remember is that same as the previous example, when we talk about an acceleration, which is, for example, 5 meters per second squared, without the direction, it means that we are describing acceleration as a scalar quantity, but there's no change in the terminology. So when we say 5 meters per second squared north, we're talking about acceleration, but this time we are not talking about it as a vector quantity. So how do we write the following? What are the different units? Again, let us recall, when we write something, for example, velocity. We write it as v or lowercase v. We write here 5 meters per second. Ano-ano to? This one here is your physical quantity, meaning this is what you're describing. 5 is the magnitude. Meters per second is the unit symbol. Okay? So what are the unit symbols for distance, speed, and acceleration? So the unit symbol for distance is x. The unit symbol for speed is a lowercase v. The unit symbol for acceleration is a lowercase a. So in terms of displacement, velocity, and acceleration, we actually have the same symbols. We have x, we have v, and we have a. So how would we know if we're talking about a vector or a scalar quantity? Since when we say it's a vector quantity, there should be a direction. What we're going to do is that we're going to put an half arrow or an arrow on top of your physical quantities symbol. Okay, so that's how you convert from one physical quantity to another, from scalar quantity to a vector quantity. Okay, so let's discuss now the difference between distance and displacement. So distance is defined as a scalar quantity that refers to how much ground an object has covered during its motion. Meanwhile, displacement is a vector quantity that refers to how far out of place an object is. It is the object's overall change in position. So let's have some example. For example, you have here point A and then point B. And for example, you are tasked to walk from point A to point B. Okay, so you can move here, 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 here because you have a choice on how do you want to go about from point A to point B. Or you can walk on a straight line. Okay, so we have here a dark blue arrow and an orange arrow. Let me put an arrowhead so I can indicate that it's an arrow. Okay, so for example, the orange arrow is about, let's say, 10 meters. Meanwhile, the dark blue arrow, let's say, is about 30 meters. Okay, so between distance and displacement, what do you think between the two arrow, the orange arrow and the dark blue arrow, defines a distance? Is it the blue or the orange? I'll pause this video. Okay, thank you so much. So the blue arrow, which is 30 meters, is the distance traveled. Since, according to our definition here, it defines as how much ground, kung gaano yung nilakad or tinakbo. Meanwhile, the orange arrow here is our displacement, which is 10 meters. Why? Because as per our definition here, displacement is a vector quantity that refers to how far out of place an object is. So, for example, we have here point A and then point B. And then from point A to point B, you move at a random direction. Halo-halo na. And then you go here. When you are asked if what is the displacement of an object, it doesn't matter if labo-labo dito sa gilid. What only matters is the distance from point A to point B. Another example, let me delete this one, is again from point A to point A. And then, for example, you moved again, like just like this one, ng labo-labong ganyan. But at the end of all, you go back to your original position. Okay? So your distance here would be kung gaano kahaba tong green. Let's just say 100 meters. However, your displacement would be 0 meters. Why? Because how far you are out of place. Meaning, if you started at point A and then you end up at point A, you're going to have 0 displacement. But kung gaano karami yung nilakad mo, that is your distance. Any questions? Okay, let's proceed. We have here two definitions, position and displacement. So what do we mean when we say position? So position is simply the specific location of an object using some convenient coordinate system. Meanwhile, displacement is a change from one position to another position. So let's illustrate this so we can understand it better. So when we say position, the most common coordinate system that we use is of course, the Cartesian plane. Okay, so we usually write it as 0 and then 1, 2, 3, 4, 5, and then -1, -2, and so on and so forth. So this should be +1, +2, +3, +4, and then this would be -1, and so on and so forth. Okay, so when we say position, when you, for example, it's here, that means that is the position of, for example, point A. We use, how do we describe now the position of point A? We describe it as point A is at x3. So wala naman unit, so x3 lang. Meanwhile, displacement is a change from one position to another position. So from point 3, for example, from 3 you move to 5, so B. So your displacement would be 1, 2. So point A has a displacement of 2, whatever kung ano man yung 2 na yon. It's either meters, centimeter, inches. So that's how we relate displacement to position. Okay, we are now to describe, since we have done with the basic, we are now to describe the realm of motion in one dimension. So pumapasok na tayo sa mundo ng how do we describe motion. In a larger umbrella, we use the term mechanics. So mechanics refers to also as a classical mechanics or Newtonian mechanics. This is concerned with how forces interact with material objects, how they move them, or how they connect. For short, it's also a branch of physics that deals with the motion of objects and the force that change. It also deals with, for example, particles that are moving either with less velocity or whether they are at rest. Mechanics is of vital importance since it describes motion of material bodies such as planets, rockets, falling objects, and baseballs. Basically anything. There are different areas of mechanics such as kinematics, dynamics, and statics. For this week, we are to focus with kinematics, which means that we are going to discuss dynamics during the Newton's laws of motions topic. So kinematics is defined as, of course, it's a part of mechanics that describe motion without regard. So that's the key word there, without regard to its cause. Here, we will focus on one-dimensional motion. So when we say one-dimensional motion, it can either be x dimension or y dimension. To recap, kinematics describes the quantitative description of motion, such as the rate of which particles are moving, such as velocity, and the rate of which their velocity is changing as described with its acceleration. Okay, the last one is statics. So statics deals with the study of forces acting on bodies at rest. When in static equilibrium, the system is either at rest or its center of mass at constant velocity. Again, we are going to describe this when we go with Newton's laws of motion. So, kanina pa natin binibanggit no, kung ano yung term na motion. But, what is motion really? So, motion is the displacement of an object in relation to objects that are considered to be stationary. Motion can also be defined as the continuous change of position with respect to a certain reference point. Again, motion can either be described as a scalar or the vector quantity. Okay, so let's now connect kinematics, dynamics, and motion. So I have here a blank page. So when we say kinematics, for example, we have here a box. Okay? For example, dumating na yung ating Shopee order. Yan. So when we say kinematics, we are talking about, for example, its movement here. For example, it has a velocity of 1 meters per second. Okay? So the box is moving 1 meters per second. Etong 1 meters per second na to, when we just focus here on its motion, we are talking about kinematics. Meanwhile, if we now to talk about it in terms of what causes its movement. For example, it's either you kick. Example, may kunyari sinipada yung parcel. Okay, kasi hindi nakuha yung gustong photocard. Okay, yan, sinipa mo daw. Okay, so the kicking motion, yung pagsipa or the force, more specifically, let me change it to green. Okay, yung act ng pagsipa or the act of giving it some kind of force that causes its motion, that is now the realm of dynamics. Now, what if wala lahat yan and then the box is just sitting still, waiting to be opened? Okay, so that deals now with statics. What causes this object to not move, or what causes of this object to move, and things like that. Okay, so now we are now going to be more specific with our how we describe motion. So a while ago, binanggit na natin yung concept ng distance and displacement. And that is important because you need to know how do you describe distance and how do you describe displacement, because they are prerequisites on how you can describe speed and velocity. So upon discussion kanina, we have described speed as a scalar quantity. and velocity as a vector quantity. So speed is defined as the total distance traveled divided by the time to travel that distance. So this is the mathematical formula. Speed is equal to the total distance over the time it took. Meanwhile, velocity is the total displacement traveled divided by the time to travel that instance, or to travel that distance, which is the change in x over the change in t. To understand this better, I have here a very simple example. We have a car that has traveled 30 meters in 10 seconds from point A to point B, and we are asked to find the average speed, and if the displacement of a car is 20 meters north, what is the car's average velocity? So we have here two situations. We have x is equal to 20 meters north, and x is equal to 30 meters, and t is equal to 10 seconds. First question is, between the red and blue arrows, what describes distance and what describes displacement? I'll pause this video for a while. Okay, so the red line describes is displacement, which means that we have to use 20 meters when we try to answer velocity. Meanwhile, the blue line indicates the distance traveled, which means we're going to use the data in the blue, which is 30 meters, to find its speed. Okay, so let's answer. Okay, so the formula for speed is speed is equal to the total distance, which is x, over time. And according to this one, that is 30 meters. So that will be 30 meters over the time it takes. So both of them, it took 10 seconds. So that will be 10 seconds. So 30 divided by 10 would be 3 meters per second. So we'll write it down here, 3 meters per second. So don't forget to box your final answer. Next, we're now to search for the average velocity, which is v, the arrowhead. And then we have here the symbol for delta, or the symbol for change. So that's delta x, which now pertains to displacement, over delta t, which now pertains to the change in time. So the change in displacement is now x2, which means the position 2, or the last position, which is 20 meters, minus the first position, which of course is 0 meters. So it started from 0 meters and then moves at 20 meters. Then we have here the change in time. Time 2 would of course be the last time, which is 10 seconds, minus of course the starting time, which is of course 0 seconds. Okay, I'll give you time to answer. The answer is 2 meters per second. As simple as that. Okay, now you can observe here the difference between how we define speed and how do we define velocity. So here, of course, we are talking about velocity, so we have to also write down the direction of this velocity. Since we're moving north, we should also write here 2 meters per second north. Okay, so that's how we answer speed, and velocity. We now have described distance and displacement, velocity and speed. We're now going to the last variable in terms of kinematics, which is acceleration. So acceleration is described as a vector quantity that pertains to how velocity changes with time. Is an object speeding up or slowing down? So the formula for that is acceleration is equal to the change in velocity over the change in time. Simply, that is actually also equal to the final velocity minus the initial velocity over the rate in change of time. So this is final and initial also. So we have here our example, which describes that if a shuttle bus comes to a normal stop and it slows down from 9 meters per second to, of course, 0 meters per second within 5 seconds, we have to search for the average acceleration of this bus. First, we need to analyze if 9 meters per second, is it the final velocity or is it the initial velocity? According to this scenario, it slows from 9 meters per second. So it slows from. The term from means that it is the initial velocity. So we put it here. Meanwhile, comes to a normal stop, so huminto, which means that 0 meters per second is our final velocity. And that is important because as you can see here, it will tell us if we have a positive acceleration or a negative acceleration. So let's try to answer. Let's find out first our given as described a while ago. Our final velocity is 0 meters per second and our initial velocity is 9 meters per second. And this all happened within 5 seconds. Let's write down our formula. Acceleration is equal to the change in velocity over time. Let's substitute this one, Vf minus Vi over t. And our final velocity, of course, is 0 meters per second minus our initial velocity, which is 9 meters per second, over the time it took for that to happen, and that is 5. And it's 9, that will be negative 9 divided by 5. So that would be about negative 1.8 meters per second squared. Okay, so as we can see here, we have a negative acceleration. So would this match our problem? I'd say it would, because according to our problem, it slows. So bumagal siya. So we have here a negative acceleration. Let's box it out. Which means that if we have here a positive value, we have a positive acceleration, the object is speeding up. And if we have a negative acceleration, the object is slowing down. For the whole duration of this week, we are just going to talk about objects which are moving at a uniform accelerated motion. So our next formulas that I'm going to show you would only be applicable if an object is at a uniformly accelerated motion. So what do we mean when we say uniformly accelerated motion. These are objects which are moving in a constant acceleration along a straight line. The motion of the object is described to be uniformly accelerated. Later, I'm going to show you the different equations of kinematics, but kindly remember that objects which has a uniform accelerated motion can be interpreted through what we call the motion graphs and can be analyzed through the equations of kinematics. So what is a motion graph? So a motion graph describes the motion of an object, which is occasionally hard to do with words. So instead of describing them with words, we use graphs to show their movement or motion. Because sometimes, of course, graphs help make motion easier to picture, therefore to understand. So what will motion graphs show us? It will show us the motion, the speed, the velocity, the acceleration, even the displacement of an object. So we have here a summary of the different motion graphs. We are to describe them and discuss them furthermore on the part 2 of this lecture series. However, it would be nice that if you have a copy of this graph on your notebook or your notepad. We are also to use the different equations of kinematics together with the motion graph. So they will go hand in hand. So what are the different equations of kinematics? Again, let us recall that the different equations of kinematics can only be used if the acceleration is constant. If it's not constant, we are to use a different formula, but that won't be part of our coverage. So these are the different equations of kinematics. Let me just describe them individually, but do not worry, we are going to use them on some of our examples. First, xi means it's the initial displacement or position, which means x defines displacement or position, and then I means initial. Kindly remember also that some references uses the term not. This parang O icon here is the not. Yan. However, we are not going to use it to avoid confusion. We also have here XF, which means it's the final displacement. We also have VI, or the initial velocity. Again, put an arrowhead. And then we have VF, which means it's the final velocity. We also have time. And we have constant acceleration. So what are the units of the different physical quantities that we're going to use? X, of course, would be in meters. If they are not in meters, you have to convert them into meters. Velocity would be meters per second, since velocity describes the distance over time. And we also have time, which of course would be in seconds, and acceleration, which would be in meters per second squared, because it describes the change in velocity over time. Okay, so which means that when we are trying to search for the final velocity, what we're going to do is to use the initial velocity, added it with acceleration and time. So this is in meters per second, meters per second, meters per second squared, and then time it took for that to happen. Next is if we're trying to search for the final position, this is in meters. We use the initial position, multiplied it by the initial velocity, multiplied by time, and 1/2 of acceleration, and then squared of time. Sorry. We're trying to search for the displacement. Okay, this can also be described as a displacement or the rate of change in xf and xi. You can also write it as delta x is equal to 1/2 vf vi. So vf and vi is in meters per second. This is in seconds. If we're now going to try to search for the final velocity squared, we use the following. And of course, we can also search for the acceleration or the time. Depending on what equation you have to use, you just have to derive them from the different equations of kinematics. Some references also just use 3 equations of kinematics, mainly this one, and this one. So usually, ito yung ginagamit, but just for you to be flexible, in-add ko na rin tong number 3 para lang meron kayong pagkukuhanan. But of course, you can just derive them. So these are the different equations of kinematics.